Hey everybody, in this video we are going to learn how to transform the graphs of quadratics, or in other words, parabolas. We tend to use the word quadratic to describe the type of equation, and parabola is describing the graph more so. Now, quadratics are most easily identified by the squared being the largest power, the dominant power of the equation. Y is, of course, to the first power when you're dealing with functions, equals x to the second power, and it's a polynomial. Now, how do squares work? Just so we could establish a bit of a pattern here. So just going to write out a couple of things up here on top of the page. 0 squared is 0, 1 squared is 1, 2 squared we hit 4, 9, 16, 25, 36, etc. dot dot dot. Now, when you're graphing this, could you do a table of values and say, okay, 0 squared is 0, 1 squared is 1, there we go, 2 squared we hit 4, 3 squared we hit 9. You can do that, but once your vertex is moved, it becomes annoying trying to plot those points with a table of values. You can mess up, or when you start stretching and reflecting and doing all that good stuff. So what is it good to know? By default, when a equals 1, the distance from one point to the next, where you left off, you're just going to go over 1 and up a certain increment, is sort of something you could easily memorize because of how quadratics are special, perfect squares are special, and how they are separated from one another. So let's take a look. Find the pattern. Plus 1, plus 3, plus 5, plus 7, plus 9, plus 11, dot, dot, dot. So increments of odd. So when you find your vertex, wherever you are calibrating your center, your vertex, your new origin to be, okay? From that vertex, if A is 1, and we're working under the assumption in all of these examples for the most part that B is just being left untouched as 1 as well. When A is 1, this is what you're going to do from your vertex, as long as it's, again, positive. Over 1 up 1, over 1 up 3, over 1 up 5, and if you have the space, over 1 up 7, and so on. And because the symmetry, like the absolute value in the previous video, since the symmetry is even, meaning it's symmetric down the middle, do the same on the other side, and then ever so carefully, with a nice curve, connect your dots. Then, if you had more room for more points, you could continue in the where your increments are the odd, consecutive odd numbers. So there we go. The end behavior, positive. So the end behavior is up on the right when it's positive, and when it's an even power, it is the same where you begin. The domain from left to right, we cover all real numbers, so we're really going from negative infinity to infinity. But the range from bottom to top, that starts here at the y value of 0 bracket because it's included, and it keeps going up, 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 up toward infinity with the parenthesis because you can never reach the value of infinity. End behavior, I sort of did this from an algebra 2 standpoint, from a calculus, pre-calculus standpoint, the limit as x approaches negative infinity. So we're saying as x goes all the way to the left, forever, ever, and ever. What does it appear we are approaching? Negative infinity squared, you're going to get infinity. And the same concept as we go to the right, forever and ever and ever, what's happening to your output or your y value? It's going toward infinity. So this here, these two statements are another way of saying that the end behavior is up and up. Okay? Now that we have that, we have an example with transformations. So rewriting it just with A is 1. X minus 3, remember this is the backward house over here where everything's a bit backwards, minus 4. So where are we going? We're going right 3 and down 4. And that's it. No stretch, compress, reflect, nothing is happening. So right 3, we get there. Down 4, we're right here. That is my newly recalibrated origin, if you will. That is where I'm centering everything around. Then I have a 1 essentially in front. It's invisible, but it's there. Over 1, out 1, out 1, up 1, out 1, up 3, out 1, up 5. It doesn't look like I have more room, so good enough. Ever so carefully, arrows on both ends right there. This is also, just to throw some vocab, this is an absolute minimum for my graph. So we'll write min, absolute minimum. There's no point lower than this. There are no maximum points on this graph, let alone an absolute or relative maximum, none of that, because it goes up forever, so we cannot define one distinct y value or output value to be the highest. Let's do a couple more examples. Again, this is keeping it light, very light. There's a a bunch of examples I'll be uploading later on that are going to be a little bit more intricate, and then later in the future, I will probably do stuff that's like super elaborate where I'm playing with the b values and all that kind of stuff, which is a lot of fun, I think. Y equals, this is really -2 x minus 0 squared plus 8. So what does that mean? So pay attention to where the invisible implied parentheses are or are not. So really we're there. So what does that mean about where we're moving? You're going right 0. You're going up 8. What else are we doing? 2 things. When A is negative, remember that's 2 transformations. You have a vertical, this is for the negative, okay? A vertical reflection. So it's going to flip that way. And the 2 is a vertical. Now this is where the first curved graph I'm doing, okay? I did linear and absolute value, they were flat. Vertical stretch of 2. I'm not going to write it. I'm saving my brain cells. Okay, so let's calibrate the right 0 and up 8. So that's going to be 2, 4, 6, 8. That is where my vertex is. It did reflect, so instead of it opening upward, that's how you would describe it, opening upward, and concave, we would call this concave up. We're going to be opening downward, and the graph will also be called concave down. It's going to look like this. Now, if this was any other day and there was a 1 in front, you go over 1, down 1, over 1, down 3, over 1, down 5, and so on. But there's not a 1 in front, it's a 2. So vertically only it is stretching. So as we saw over here, what is the impact? Vertical stretch. You're pulling away from your origin or your new center origin. Vertically only, the width of the word graph doesn't change, right? Only the height or the distance in the vertical direction will change. So out 1, down 2 instead of 1. You're doubling everything. So 1, 3, listen carefully and think about it. You're not adding 2. 1, 3, 5 will become 2, 6, and 10. So over 1, down 2, instead of 3 next, we go over 1, down 2, 4, 6. Over 1, down 2, 4, 6. And I can't really fit more than that. There we go. It should be round, not pointed. So do your best to really round it out. It's smooth, round, continuous. And there you go. That's the end of that example. The next one, fairly simple again. Nothing too crazy. Like I said, this is a light set of examples. So this is going to be moving which way? We're going left or right? We are going right 5, up 3, if you're taking a test, I would say if they're not labeled tick marks and you're counting it out, I would label the numbers you care about. So in this case, 5 and 3, because if you miscount and label it correctly, it looks better because then the teacher knows what you meant versus you miscounted and you didn't label it. Hopefully that makes sense. Now, negative is a vertical reflection. Now, if I do a horizontal reflection, on a parabola or an absolute value, then it's switching sideways and it doesn't make a change. So that would be silly. Over 1, down 1, over 1, down 3, over 1, down 5. I know it doesn't fit, but I'll still put a point to guide me. And there we go. The vertex, that point, ordered pair, is 5, 3. So there's that point. That's your maximum. There's tons of word problems about parabolas, and they're always asking you, at what time will the maximum blah, blah, blah occur? What is the maximum value? Just to reinforce what I just said. At what time or when, under what conditions, does the maximum value occur? It's the x value of the vertex. What is the maximum value? It's the y value of the vertex. Or it could be for the minimum. It could be something parabolic opening upward. It's still the same idea. You're looking for the vertex. If it's not in this form, if it's in standard form, which is ax squared plus bx plus c, negative b over 2a will get you the x value of your vertex, and you take that value, plug it into the function or equation, to get your output or your y value that corresponds to that x value to get the full ordered pair for your vertex. That's exactly 10 minutes, so that means I'm officially over. Hopefully you understand how to graph some very, very, very basic parabolas and you feel pretty good about it. Thumbs up if you at least have a decent understanding. Comments, questions, go to the comment section, talk to each other, talk to yourself. Maybe I'll answer if I have time. The next one I will be graphing is the cubic. I already did linear and absolute value. They're all on the playlist, and I will set up thumbnails when I have time. I don't right now. Adios. Thumbs up.